on Mars. A new study published in the journal Science showed definitive advice of organic matter on the surface of Mars. The data was collected by NASA's nuclear power rover Curiosity. It confirms earlier finding that the red planet contain carbon-based compounds. The compounds, also called organic molecules, are essential ingredients for life as a scientist understand it. The organic molecules were found in Mars-scale crater. A large area may have been a watery lake over there billion years ago. The rover uncovered traces of the molecule in rock extracted from the area. The rocks also contain sulfur, which some scientists speculate helped preserve the organic even when the rocks were exposed to the harsh radiation on the surface of the planet. Scientists are quick to state the presence of the organic molecule is not sufficient advice for ancient life on Mars, as the molecules could have been formed by non-living process. But it's still one of the most astonishing discoveries, which could lead to future revelation, especially when one considers the other startling find that Curiosity uncovered around 5 years ago. The rover analyzed the iron immediately, and in 2040 it found the iron contained another of the most basic organic molecule and a key ingredient of natural gas. Methane, of the characteristic of methane is that only survives a few hundred years. This means that something somewhere on Mars is replenishing the supply. According to NASA, Mars emits thousands of tons of methane at a time. The level of methane rises and falls at seasonal intervals in the year, almost as the planet is breathing it. NASA suspects the methane comes from deep under the surface of the planet. The variation in the temperature on the surface of Mars causes the molecule to flow upward at the higher of the lower levels. For example, in the Martian winter, the gas could get trapped in the underground icy crystals. This crystal, called crystals, melt in the summer and dissolve the gas. However, the source of the methane is still a complete mystery. The world of astrobiology considers both of the studies as historical milestones. According to this information, Mars is not a dead planet. On the contrary, it is quite active and may be changing and becoming more habitable. Of course, this means further research is necessary. Society said that need to send new equipment to Mars, equipment that can measure the air and soil with more precision. There are already missions underway. The European Space Agency ExoMars ship lands in 2020 and will be able to drill into the ground on Mars to analyze what it finds. Additionally, NASA is sending another Mars rover in the same year to collect samples of Martian soil and return them to Earth. The possibility of life on Mars has fascinated humans for a generation. It has been the subject of endless science fiction novels and films. Are we alone in the universe, or have there been other life forms within our solar system? If the current mission to the Earth planet continue, it looks looks as if we may discover the answer very soon. How humans evolved language. Thanks to the field of linguistics, we know much about the development of the 5,000 plus language in existence today. We can describe their grammar and pronunciation and see how their spoken and written form have changed over time. For example, we understand the origins of the Indo-European group of language, which include Norwegian, Hindi and English, and can trace them back to tribes in Eastern Europe in about 3000 BC. So, we have mapped out a great deal of the history of language, but there are still areas we know little about. Experts are beginning to look to the field of evolutionary biology to find out how the human species developed to be able to use language. So far, there are far more questions and hope theories than elsewhere. We know that human language is far more complex than that of even our closest and most intelligent relative, like chimpanzees. We can express complex to convey subtitle, emotion, and communicate about abstract concepts such as past and future. And we do this following a set of structural rules known as a grammar do only humans use in innate system of rules to govern the order of words. Perhaps not, as some research may suggest dolphins share this capability because they are able to recognize when these rules are broken. If we want to know where our capability for complex language come from, we need to look at how our brains are different from other animals. This relates to more than just brain size. It is important what other things our brains can do and when and why they evolve the way. And for this there are very few physical clues. Artifacts left by our ancestors don't tell us what speech they were capable of making. One thing we can see in the remains of early humans, however, is the development of the mouth, throat, and tongue. By about 100,000 years ago, humans had evolved the ability to create complex sounds. Because that evolutionary biologists can only guess whether or not early humans communicated using more basic sounds. Another question is, what is about human brains that allowed language to evolve in a way that it did not in others primates? At some point, our brains become able to make our mouth produce vowel and consonant sounds, and we develop the capacity to invent words to name things around us. These were the basic ingredients for complex language. These were the basic ingredients for complex language. The next change would have been to put those words into sentences, similar to the proto-language children use when they first learn to speak. No one knows if the next step, adding grammar to signal past, present and future, for example, or plurals and relative clauses, required a further development in the human brain or was simply a response to our increasingly cheap benefit while living together. Between 100,000 and 50,000 years ago, we start to see the advice of early human civilization. Through cave painting, for example, no one knows the connection between things and language. Brains didn't suddenly get bigger, yet humans did become more complex and more intelligent. Was it using language that caused their brains to develop, or did their more complex brains start producing language? More questions lie in looking at the influence of genetics on brain and language development. Are there genes that mutated and gave us language ability? Researchers have found a gain mutation and that occurred between 100,000 and 200,000 and 100,000 years ago, which seems to have a connection with speaking and how our brains control our mouth and face. Monkeys have a similar gene, but it did not undergo this mutation. It's too early to say how much influence genes have on language, but one day the answer might be found in our DNA. I think that's all for me. Thank you for your attention and see you in the next video.